What is a stack frame in GDB? Imagine you're trying to solve a mystery in your program. To do that, you need to see what happens step by step. That's where GDB, the new debugger, comes in. It helps you look into your program's inner workings. One key part of understanding what's happening is knowing about stack frames. A stack frame is like a snapshot of a single function call. Every time your program calls a function, a new stack frame is created in the call stack. Think of the call stack as a stack of plates, with each plate representing a function call. The bottom plate is usually the main function, and each new function call adds a new plate on top. Each stack frame holds important details about that specific function. It stores the arguments passed to the function, the local variables declared inside it, and the return address. The return address is where the program should go back to after the function finishes. This setup helps the program keep track of where it is and what data it's working with. When you use GDB to debug, you can see these frames. GDB automatically shows you the current frame when the program stops. But you can also move between frames using commands like frame, up, and down. This lets you look at different parts of the call stack and see what each function was doing. The call stack is like a trail of breadcrumbs leading to the current point in the program. If a function calls itself recursively, multiple frames for that same function can exist at once. GDB uses a process called unwinding to move from one frame to the next, following saved frame pointers or return addresses. Knowing how to navigate these frames is super helpful. You can use where or backtrace to see the full call stack. Then, switch to a specific frame with frame or up and down. This way, you can inspect the variables in each function, helping you find bugs or understand how your program reached its current state. You can also examine the memory directly if needed. For example, using commands like X on the stack pointer can show you how the frames are laid out in memory. This is useful if you suspect stack corruption or other low-level issues. Mastering stack frames in GDB is a powerful skill. It helps you trace your program's execution, see what data each function was working with, and find bugs more efficiently. Whether you're fixing a crash or understanding complex code, knowing about stack frames makes debugging much clearer and more manageable.